have this paper here which has 4 sides. I'm going to use this as hydrocarbon with a carbon at the center where my thumb is pointing. And then the 4 different groups attached are X, W, Q, and then Y. Okay. So the chiral center is where thumb is pointing, or the chiral carbon. My thumb is pointing. In this, you'll see that the Q and W are in the plane of the board. Then X is pointing towards me, facing the camera, and then Y is away from me. Okay. So I can draw this on the board. Now if I invert this vertical inversion 180 degrees, you see that X is still pointing to me, but it's gone up on the wedge, and then the W and Q which positions in the plane. So I'm going to get something like this, where now this side is W and this side is Q, and Y is still pointing away from me. Okay, so this is 180 degrees vertical. So back to this, which is this. Okay, if I turn this like 90 degrees, the X and Y will be in the plane, and then Q will be pointing towards me, and W will be pointing away from me. So 90 to 1 W away from me. Again, if I do 180 degrees vertical, now Q is still pointing to me, and W is going away, but here on the lower side of the wedge, and then the plane like this, X is here, Y is here. So that's how that looks like. So we can manipulate this, and all these are the same compound, just I've turned them in different angles. So you come across something like this a lot, where they'll give you a compound and they'll ask you whether it's the same or not. So that's how this is. These are all the same, but I've turned them through different angles. Some angles you see that groups are in the plane are now pointing in and out. This is very good because you can use this as a quick reference in examinations where you don't have your model kit. You can still have a paper as your model kit. We have organic molecules drawn as 3-dimensional structures on the board. I'm supposed to determine the RNS configurations. Now I have this improvised model kit. I made this from paper. Just cut 2 pieces of paper and then mold them together like this. You can staple the center and then use your thumb as the center for the chiral carbon. So for instance, in this case I made this in such a way that the X written here pointing in the camera towards me is my OH, and then the Y on the opposite end is my bromine, and then Q is my methyl group, and then W is my ethyl group. So this holds on very well. Now if I want to assign the stereochemistry, all that I need to do is look at my lowest substituent, which in this case is the Q, and then hold it like this. So now my lowest substituent is in my palms right here. I don't see it anymore. And then look at the three substituents that are left or that remain to be seen. And then over here my bromine, which is Y, is my highest priority, and then my X is my next highest, which is the OH. Then W is hanging in there, which is my ethyl group. Okay, so I need to go from the highest to the next highest to the next one. I need to go from Y to X to W. Now that's a counterclockwise movement. Starting from Y to X, that's moving counterclockwise, and therefore this is S configuration. You can do the same thing for this one. Sometimes you'll come across a structure that looks like this. This situation is very confusing to a lot of students. So in this case, if you see a structure like this, what you do is this side shouldn't actually be here. It has to be above here. So just redraw the molecule, bring this side the same thing up. Okay. So this is still pointing towards you. This is pointing away. And this is the same as it is. This wedge shape is still the same. So instead of writing this up, they just want to do it like this, pointing towards you, and this pointing away. But technically, this is how it's supposed to be written, so that you can easily assign the RNS configuration. So if you're just using this, you get the wrong answer. But if you use this, you get the right answer. So if I use this to assign the RNS configuration, I'll get this highest priority followed by this. So I'll get an S. But if I use this, I'll get an R. So just be careful about things like this. As soon as you see this, just arrange it this way so that the wedge is very distinct. Put all the wedges on one side, and then the planar groups should also be on one side. That will help you to easily determine the RNS configuration. So all the wedges. On one side. Planar groups on one side. Okay, so this is very important. This will make it easy for you to determine the harness configuration for chiral centers. So this is very tricky. If you just use this, you get the wrong answer. This is the correct answer. Okay, I was trying to find the harness configuration of the structure. So assuming X is bromine, Y is OH, Q is methyl group, and W is ethyl group. So just hold the lowest priority. Go from my highest to my next highest to my next. That is R configuration. So this helped me to determine the harness configuration of this. But if I don't have this, I can still redraw it in this form and then put all the wedges on one side. And I'll get the structure. Then I'll rearrange to get the lowest priority going to the back, and then assign it, and I'll get the same answer. Even if the bromine is switched on the other side, it should still be pointing towards me, and the other one is pointing away from me. This will also give me the same answer. So all these are representing the same compound.